All right, let's get right into it. Deep inside you, right this very second, there's a silent, microscopic war happening. It's this constant, epic battle between your body and literally trillions of potential invaders. So today, we're going to pull back the curtain on your body's secret army, the incredible, complex, and honestly, brilliant immune system.
I mean, just think about that for a second. It's a staggering thought, right? Every single breath you take, everything you touch, it's all just teeming with potential threats. So how on earth do we survive, let alone thrive, in that kind of environment? Well, the answer is this incredibly sophisticated defense network that is, no joke, more advanced than any military on the planet. Let's break down how it all works.
You know, before you can fight an enemy, you have to be able to find them. So the first part of our story isn't actually about the soldiers, it's about the amazing infrastructure that makes their job even possible. Think of your body as this massive, sprawling fortress, and any good fortress needs a top-notch surveillance and logistics network. And for us, that's where the lymphatic system comes in.
To get a sense of the scale here, just picture this. Your blood vessels, they're not perfectly sealed pipes. Your tiniest vessels, called capillaries, are actually designed to be a little leaky. They're constantly seeping out a fluid called plasma, that's the liquid part of your blood, to get oxygen and nutrients delivered right to your cell's doorsteps. And we're talking about 3 liters a day leaking out. That's more than a giant soda bottle's worth of fluid.
So once this fluid is outside the blood vessels, it gets a new name, interstitial fluid. You can think of it as the vital broth that all of our cells are living in. It drops off the good stuff and picks up all the waste. But if this fluid just kept building up, we'd all swell up like balloons. So how does the body handle all that cleanup?
And this is where the lymphatic system shines. It's basically the body's essential drainage and recycling service. It's this huge network of vessels that soaks up all that excess fluid, which we now call lymph, and it starts the process of getting it all back to the bloodstream. Without this system, that fluid would just pool in our tissues, causing a really serious swelling condition called edema.
But here's the really clever part. There's a huge difference in their design. Blood vessels are a two-way street. Stuff can go in and out. Lymphatic vessels, though, they are strictly a one-way street. Their walls are made of these overlapping cells that act like tiny little swinging doors. Fluid can push its way in from the tissues, but it can't leak back out. All roads lead back to the bloodstream. It's simple, but it's genius.
Now, as this lymph is traveling, it doesn't just get a free pass back to the blood. Oh no, it has to go through security first. You've got somewhere between 500 and 600 of these little bean-shaped organs called lymph nodes scattered all over your body. These are the command centers, the security checkpoints, packed with armies of immune cells that are constantly inspecting the fluid for any sign of trouble.
Okay, so our surveillance network is in place, and it's running smoothly. But what happens when the fortress walls are breached? What happens when you get a splinter and it brings some bacteria along for the ride? Well, that's when the alarm bells start ringing and the first responders get scrambled into action.
We've all experienced inflammation. You know, the redness, the heat, the swelling. We usually think of it as the problem, but it's actually the solution. It's the body's emergency broadcast system. When a cell gets damaged, it sends out chemical alarms, like histamine. This tells the nearby blood vessels to get wider, which brings more blood to the area, and that's what causes the redness and heat. The vessels also get leakier, allowing fluid and immune cells to flood the zone, and that's where the swelling comes from.
Arriving on the scene is the innate immune team. These are your general-purpose, fast-acting first responders. They're not picky, they just attack anything that looks like it doesn't belong. You've got your macrophages, the big eaters, that just gobble up invaders and junk. Then you have the neutrophils, the absolute frontline soldiers who fight so hard they actually die in the battle, and their remains are what form what we know as pus. And then you have the natural killer cells, who have the super important job of taking out our own cells that have been compromised by a virus or have turned cancerous.
Now, this innate team is amazing, but sometimes they run into an enemy that's just too smart, or there's just too many of them. And when these first responders start to get overwhelmed, they make a call. It's time to bring in the special forces, the adaptive immune system. They're a lot slower to get going, but once they arrive, they are absolutely, ruthlessly effective.
And this really gets at a fundamental trade-off in our immune system. The innate response is super fast, but it's general. It recognizes broad patterns, kind of like, yep, that's a bacterium. The adaptive response, on the other hand, is much slower. We're talking days to get mobilized, but it is incredibly specific. It learns to recognize one single unique enemy and then designs custom-made weapons just for that one bad guy.
And here they are, the elite squad. First, you've got the helper T cells. Think of them as the battlefield commanders. They don't do the fighting themselves, but they analyze the threat and then they release chemical orders, called cytokines, to direct the entire attack. Then, following those orders, you have the cytotoxic T cells, the elite assassins, trained to hunt down and eliminate only the specific body cells infected with this one particular enemy. And finally, you've got the B cells. When they get activated, they transform into these unbelievable weapons factories, just churning out millions and millions of tiny protein missiles.
And these little protein missiles, they're called antibodies. Each one is custom designed to lock onto one specific invader, kind of like a molecular homing beacon. They can physically gum up the pathogens, literally clumping them all together so they can't do anything. Or they can act like a tag, marking the invaders for destruction and making them look extra tasty for those big eater macrophages. They are the ultimate smart weapon.
So, the battle is won. The specialists have cleared out the infection. But the most incredible part of this whole adaptive immune system isn't just that it wins the war, it's that it never, ever forgets an enemy it has faced. And this is the secret to true immunity.
Just think about the very first time you get sick with a new bug. That initial response is slow and pretty weak, relatively speaking. That's when you actually feel sick, because your body is still learning how to fight it. But after that battle is over, your adaptive system creates memory cells. So the second time that exact same invader shows up, the response is unbelievably fast and powerful. It often just wipes out the threat before you even feel a thing.
This right here is the whole point. Immunological memory. It's the reason you usually only get something like chickenpox once. The second time that virus shows up, your body's secret army recognizes it instantly, unleashes this devastating counterattack, and wipes it out before you even get a sniffle. You are immune.
I mean, it is an almost perfect system of defense, but its power, its ability to tell the difference between you and not you, is a serious double-edged sword. So the critical question becomes, what happens when this incredibly powerful army gets confused? What happens when it turns its weapons not on an invader, but on you? Well, that's where things like allergies and autoimmune diseases come into play, but that's a whole other story for another time.